Um, the what I want to look at is how continuing with the current industrial model of livestock production will place several of the UN Sustainable Development Goals, the SDGs, out of reach. I then want to examine how rethinking the role of livestock could actually make a positive contribution to reaching the SDGs. Industrial animal agriculture outcompletes small-scale food producers, thereby undermining their livelihoods. And this gets in the way of achieving SDG 1's aim of ending poverty. Indeed, in 2018, the then Director General of the UN Food and Agriculture Organization said that we must ensure that small-scale livestock producers and pastoralists are not pushed aside by large capital-intensive operations. Industrial livestock production is dependent on feeding human edible cereals, wheat, maize, barley to animals. Globally, 40% of cereals are used as animal feed. But in countries with very large industrial livestock sectors, the figure is much higher. So in the EU and US, around 2/3 of cereals are used as animal feed. And animals convert these very inefficiently into meat and milk. For every 100 calories of human cereals fed to animals, just 17 to 30 calories enter the human food chain as meat or milk. And for every 100 grams of protein in human edible cereals fed to animals, just 43 grams of protein enter the human food chain as meat or milk. And indeed, some studies show that this conversion is even poorer than this. This is staggeringly inefficient and undermines the SDG 2 aim of achieving food security. And industrial livestock's huge demand for cereals has fueled the intensification of crop production. And this, with its use of monocultures and agrochemicals, has led to soil degradation, overuse and pollution of water, and biodiversity loss. And this undermines the SDGs on the environment, numbers 2, 6, 14, and 15. And indeed, 77% of the world's soy is used to feed animals, mainly in the intensive pig and poultry sectors. And this drives deforestation, so undermining SDG 15's aim of halting deforestation. Do excuse my voice. I want to look at how industrial livestock contribute to water pollution. The fertilizers that are used to grow feed crops for industrial livestock have high levels of nitrogen, but the crops only absorb 30 to 60% of this nitrogen. In other words, 40 to 70% is lost to water or the atmosphere. And then the crops that are fed to animals, to industrial animals, also have high levels of nitrogen. But pigs only assimilate about 30% of this nitrogen, poultry 45%. Most of the nitrogen is excreted in the manure. So what happens to all this unabsorbed nitrogen? Well, it washes into rivers and lakes, and it leaches from soils into groundwater, and it damages wetlands and marine ecosystems. And it causes air pollution and emits nitrous oxide, the most aggressive of the greenhouse gases. And indeed, livestock are responsible for 14.5% of global greenhouse gas emissions. And many studies show that this is going to make it impossible to meet the Paris climate targets and SDG 13 on climate action. Industrial livestock production, the stressful, crowded conditions of industrial livestock production can lead to the emission, the spread, and amplification of pathogens. Indeed, a recent study said that large pig and poultry farms are where the genetic reassortment needed to produce pandemic influenza strains may most likely occur. And another study has said that a certain way to reduce the risk of zoonosis is to reduce dependence on intensive animal-based food production systems. Continuing with these systems undermines the SDG 3 aim on achieving good health. And these industrial systems are dependent on the routine use of antibiotics to prevent the diseases that are otherwise inevitable when animals are kept in poor conditions. This leads to antibiotic resistance in the animals. This can be transferred then to people, so undermining the key medication we need to treat serious human diseases. And this damages SDG 3. I now want to look at how transforming the role of livestock can actually help deliver many of the SDGs. Small livestock farmers in the global south should be helped to improve their health and nutrition of their animals, as this would lead to increased productivity and longevity. And this would improve the purchasing power of farmers, enabling them to buy the food they don't produce themselves, and to have money available for other essentials such as education and healthcare. As I've said, industrial livestock converts cereals very inefficiently into meat and milk. Animals only make a positive contribution to food security when they're converting materials we can't consume into food we can eat. So animals should be fed on grass, on crop residues, on byproducts such as brewer's grains, citrus pulp, and sunflower meal. And they should be fed on unavoidable food waste, on, for example, fruit, vegetables, bakery products that are no longer suitable for human consumption. If animals were mainly fed on such materials, with the use of soy and cereals being, for animal feed being minimized, there would be a huge boost to the SDG 2 aim of achieving food security. Indeed, studies show that if the cereals currently used to feed livestock were instead used for direct human consumption, an extra 3.5 billion people could be fed each year. But if animals were only fed on such materials, on grass, byproducts, food waste, there would be insufficient feed to maintain current levels of livestock production. There would be a global reduction of about 50% in production and consumption of meat and dairy. And that would have to take place mainly in the global north, in Europe, America. And this may sound radical, but many studies show that a reduction of this level is needed if we're to meet the Paris Climate Agreement and SDG 13 on climate action. And if the number of livestock being reared globally were reduced, there would be a big reduction in demand for cereals and soy as feed. And this would lead to lower prices for these crops, making them much more accessible to people on low incomes. But if we no longer were producing cereals and soy as animal feed, this would free up huge amounts of arable land and make it feasible for us to move to regenerative agriculture. Now, regenerative agriculture is able to minimize the use of synthetic pesticides and chemical pesticides and synthetic fertilizers, and is able in the global south to often increase productivity. And it does this by supporting and indeed harnessing natural processes. So regenerative agriculture builds soil fertility through the use of composts and cover crops and rotations, animal manure and nitrogen fixing legumes. And instead of chemical pesticides, it uses integrated pest management. This involves, for example, allowing the natural enemies of pests to thrive, while pesticides tend to kill them. And it means building soil quality, because this can promote strong, healthy plants, which are better able to resist disease and pest attacks. And it involves using rotations, which can impede the buildup of diseases and pests, which often occurs when the same plant is continuously cropped. And regenerative agriculture can conserve water by building good soil structure, which is able to retain water, which is so vital at times of floods and drought. And all this move to regenerative agriculture would have massive benefits for the environmental SDGs. And animals have a vital role to play in regenerative agriculture. Their manure helps build soil fertility and structure, so helping to store carbon in the soils. But the amount of manure produced should be no greater than is needed to support crop production on the farm or nearby farms. And animals can convert food waste and byproducts into nutritious food, so recycling nutrients into the food system. And in regenerative agriculture, the greenhouse gas emissions from livestock and the production of their feed can be compensated for by carbon capture in pasture, soils and trees on the farm or nearby farms. SDG 3 focuses on good human health, but to achieve this, we also need good animal health. Animals should be kept in health-oriented systems, systems in which good health is inherent in the farming method rather than being propped up by routine use of antimicrobials. And these health-oriented systems would reduce the use of antimicrobials and lower the risk of zoonoses and pandemics. So what would these health-oriented systems look like? Well, they would avoid overcrowding, as this tends to lead to the transmission and amplification of pathogens. And they would minimize stress, as this undermines animals' immune systems. They would ensure that animals can engage in their natural behaviors, as inability to do so is highly stressful. There'd be no early weaning of pigs, as this involves multiple stress factors. These health-oriented systems would avoid excessive herd and flock sizes, because very big flocks and herds provide a virus with a constant supply of new hosts. It's able to move very quickly among them, often mutating as it does so. And in these circumstances, highly virulent new strains are likely to rapidly emerge. These systems would avoid mixing of different groups of animals, because this can pass disease from one group to another. They would ensure good air quality, because poor quality, high levels of dust, ammonia, carbon dioxide can lead to respiratory disease. And crucially, they would avoid the use of animals genetically selected for very fast growth and high yields, because these animals are very susceptible to metabolic and immunological problems. To conclude, if we continue as we are with industrial livestock production, this will place several of the SDGs out of reach. Whereas we transform the role of livestock in farming, and if we move to regenerative agriculture, stop using cereals and soy as feed, and globally reduce levels of meat production and consumption, then we can actually, our food and farming can make positive contribution to meeting several of the SDGs. Thank you, and once again, apologize about my voice.